Hello, ladies and gentlemen. Thank you very much for joining me for this session in this rather unusual setting of a conference talk. So today we will be talking about deploying Kubernetes without losing your sanity and breaking the bank with K3s. First, a little bit about me. I'm Janos Pasztor, and I used to work as a DevOps engineer, and for about 1.5 years, I work as an educator. That means that I teach people how to use the cloud, how to do automation, and of course, container technologies. You can always find me on these addresses. They're all listed on my website, pasztor.at, as well this slide deck as well, once I do the visual overhaul that I was planning for a while. Now, where do I come from? Why did I pick this talk? I'm a big fan of containers. They're very useful to deploy things, to put things out there. And I started using Docker 3 or 4 years ago to deploy applications to build a rather large environment. At the time, Kubernetes wasn't really a big thing, it wasn't really stable. So I went with plain Docker. In my previous job, I ran over 1,000 Docker containers in production, and it worked quite well, to be honest. Now, why do I even consider switching from Docker? When you go for a Docker Swarm, you do a Docker Swarm init, you do a Docker Swarm join, and then you're happy because you can deploy your containers, you can manage everything from a central place, and it will even account for node outage. So if a node fails, you can simply replace that node with a new node in the cluster. Things become a little more difficult if a master node fails, but that's also doable. However, there are three main pain points, among others, with Docker Swarm. First of all, there are no pods. Pods in Kubernetes mean that there are more containers that share, for example, the same network namespace. And if you're deploying an application such as a PHP application, then the pain is real. Because, for example, you need a web server in one container and you need a PHP FPM in a second container. And these need to talk. In Docker Swarm, the Nginx and the PHP FPM can be located far away from each other because Docker Swarm just launches containers wherever there's space. And that is causing a problem because of latency and unnecessary network traffic. It would be much better if Nginx and PHP were located on the same server and would share the same network stack. So you basically can talk across localhost. This is something that Docker Swarm does not do. The second problem with Docker Swarm is that there is no stateless way of deploying. What does this mean? When I deploy a Docker Swarm cluster, I definitely have to start with one node, do a Docker Swarm in it, then copy the token, the join token, and to the other servers, and then I can only join from the other servers. This works well if you're deploying Docker Swarm manually, but it doesn't work so well if you're doing it using, for example, Terraform, because Terraform is expecting everything to be a little bit more stateless. So I was looking for a solution where I could just simply say 3 servers, there you go, there's the other servers, and join together into a cluster. And the third one is that the storage management is incredibly limited. The problem with Docker Swarm is also that by default, you can, of course, mount volumes from the host machine, but then when a container gets moved over to a different server, then the data is not there. So then you need to play around with labels to make sure that your, for example, MySQL server is running on the server where actually the data is, and so on and so forth. There are, of course, storage plugins that can use Elastic Block Storage on Amazon or NFS or other things, but the options and the documentation is rather lacking. Not to mention a couple of other things, such as the lack of permission management, which you would need, for example, to deploy an application. You do not want to give your CI/CD system root permissions on the host operating system, which you very much have to with Docker because there is an all or nothing approach. If you have access to the Docker socket, then you are basically root on all the host machines. So Kubernetes. Kubernetes was developed from an internal system, as far as I know, by Google, and they have built it to address Google scale problems. And then, of course, a lot of other companies like IBM, like Red Hat, etc., joined in, and everybody is now going crazy about Kubernetes, that it is the hot new thing that will solve all our DevOps problems. And you will see during this talk that this is not exactly the case. So how does Kubernetes work? The idea is that you take your machine, your CI/CD system or your laptop, and then you talk to an API. This API is, of course, an HTTP API, which makes it rather simple to integrate with other software. Then you have a bunch of servers, these are workers, and Kubernetes is managing these servers and decides, okay, this container should run on that server. If that server goes down, then Kubernetes decides that this container should then be relaunched on another server. And it, of course, manages storage and whatnot, and does a lot of things. It can do batch jobs, so it can basically almost replace your queue system that you're using by simply scheduling containers in a specific way, which sounds like a terribly good idea because this is basically a task management for your whole application. Now, how does this look like? So your laptop or your CI/CD system talks to a component called the Cube API server. And this is, again, these are things that I found during my research. I'm not necessarily an expert on Kubernetes, but I've been doing a fair bit of digging in this area. So the Cube API server is kind of the central piece that all the other components talk to. This is an HTTP server that you can talk to. It usually is deployed doing certificate authentication. This is like you would use an HTTPS certificate, except the client also has to have a certificate. Then you have the Cube Controller Manager, which is kind of like this big ball of controller utilities. Like there's the replication controller and some other controllers, which I don't even know by heart, that deal with certain aspects of managing where certain pods are running. Remember, pod is a collection of containers. So that's kind of like the brain of the whole thing. And then there's, of course, the Cube Scheduler. The Cube Scheduler takes care of, okay, this specific pod needs to run on a certain worker node. And then there is a bunch of other stuff. For example, there is the Kubernetes Autoscaler, which is talking to cloud providers to provision new nodes in the cloud if you need more resources in your environment. For example, you say every container needs 1 GB of RAM, and if you run out of RAM, then the Kubernetes Autoscaler can talk to your cloud account and say, hey, I need one more server, please make me the server. Or if a server goes down, then it can remove that server from Kubernetes itself. There are a lot of other integrations that you might want to investigate. And this kind of highlights how Kubernetes is built. It's built as an incredibly modular system. You can put it together as you see fit, and the responsibility of putting it together is on you. So if you're installing Kubernetes yourself, or even if you're taking a managed Kubernetes by a provider, then you have this problem of, okay, there is this massive landscape of things that I can use. Which ones do I pick? And that's where the whole problem with Kubernetes comes along. There are just too many ways of deploying it. And of course, as you see, there's the kubelets. They also talk to the API server. The kubelets, of course, are running some other stuff like the kube proxy. There is core DNS, which does the internal DNS resolution. You need to deploy an overlay network. So lots and lots of stuff goes into making a Kubernetes cluster work. Now, how does this look like under the hood? You have a database. This database stores the state of the cluster because, of course, you need to remember which container is running where and what's the latest status, etc., etc. So you need to store all this data. Sounds very simple, but it isn't. Why is it not? Because if you want to build a highly available system, then you have a little bit of a problem. Since you normally, when you do, for example, a MongoDB database or even a MySQL with replication, that's usually an asynchronous replication, or as it's usually called, it's eventually consistent. This means that the eventual consistency means that the database, if left alone, will eventually be on the same state on all the servers. But that's not good enough for something that's managing a cluster. What you need here is synchronous replication. You need all the servers that act as Kubernetes masters to be in the same state. You need all the servers to see the same data. And this is usually achieved. Oh yes, and there's of course the kubelets, nice little animation here. So this is usually achieved with a database called etcd. etcd is a synchronous database where you write the data into one node and you only get an acknowledgement when it has been properly synchronized. Now, this sounds good, but again, since this is a very high level of consistency, you do need significant resources, and it is slower than, for example, a MongoDB. So let's take a look at the requirements of etcd. From what I can gather, the minimum setup requires 2 gigabytes of RAM. It also requires 80 gigabytes of an SSD, and all this is per master. So I can't exactly tell you how much you will need for your cluster, but this is the very minimum, which sounds like quite a lot if you are, for example, like me, and you want to deploy your personal website. You're unlikely to go with a Kubernetes solution here. And this was bugging me because Kubernetes has cool features. So I was thinking about, okay, shall I switch from deploying my website with Docker Compose to deploying it with Kubernetes, which as an educator would be good because then I could show people, look, you can actually do this. So my research went into this direction because at the end of the day, you had, even if I go with Amazon, I look at T3 small servers, which have 2 gigabytes of RAM. You can take 3 of those, and then they take 240 gigabytes of elastic block storage. That runs me about $70 a month. And the T3 instances are actually a little bit of a problem because they're bursting instances. So I have to do all kinds of monitoring there. And in general, if you want a production grade environment, you probably end up investing into something much more expensive, which might not be a big problem for a big company. But if you're a small company, you're a dev shop, you're doing some internal development, then running this HA setup is definitely a problem. You can, of course, go another way and just say, okay, I'm just going to have one master. And if that one master goes down, not such a big deal. I have backups, I can restore it, and I will just lose my capability of changing the state of the cluster for a couple of minutes. But you have to work around that. Now, what do we have to do if we want to deploy Kubernetes ourselves? Assuming again that you're not using a hosted solution, which does come at a price, you have to adjust at least all these config files, and I'm sure I missed some. So you have to create a kube config for the individual servers, the kube proxy, the kube controller manager, so all the components that we listed before. And I do believe I actually missed out the API server on this slide, some encryption config, etc. So that's a lot of config files that you do need to manage. And of course, if you're creating everything by hand, then this looks like, okay, just going to follow the steps in the wiki. But if you want to automate these, then that's another hurdle that you have to, it's basically a code base that you need to maintain. So you have to think about this like potential technical debt. Like a coder would not create additional lines of code just for the hell of it, because you might end up having to update that later on. And this also comes from Kelsey Hightower's Kubernetes the Hard Way, which is an excellent tutorial to understanding Kubernetes. Now, apart from the config files, you have to also ensure that, as I said, everything is an API, so the components need to talk to each other. So you will need to make sure that the components can talk to each other in a safe way, and nobody who accidentally has access to, say, the Kubernetes API or the Kubelet API can just wreak havoc in your cluster. And that is usually done using certificate authentication. Yes, much like you do put HTTPS on a website. So that is done using certificates. And these certificates are, as far as I can gather, the following. Yes, even more stuff to deal with. And these have to be managed in a private certificate authority infrastructure. These have to be renewed. And that also comes with a problem because every the kubelet needs probably a separate certificate if you want to go very secure, etc., etc. So every time you provision a server, you will have to provision a certificate there. You need to make sure these are secure and not lying around in some open object storage bucket or such, so on and so forth. And of course, certificates expire, so you either set them for 10 years, which anybody who does certificates professionally will tell you is a bad idea, or you will have to renew them regularly, which means that you will have to go in and re-provision your whole Kubernetes cluster with new certificates quite frequently. Alternatively, of course, you could take a look at the documentation, which says each minor release branch is maintained for approximately 9 months. So if you are set on a certain version, then you will have to update your Kubernetes cluster every 9 months. And anyone who has done this already will tell you that it's a bloody nightmare, because you have to pull up individual components in a very specific order. It doesn't really lend itself to doing immutable infrastructure, for example, with Terraform, because you have to kind of watch out, okay, which component do I replace first? So every 9 months, you can expect a major change in your infrastructure, and you will have to test this update, etc. So you probably end up replacing your whole cluster anyway. So you might as well just reinstall everything and switch over to the new cluster, which is usually what people end up doing. So I was looking at all this and saying, why the bloody blazes is everybody jumping at Kubernetes? And I think this is something to do with the Gartner hype cycle. It starts with an innovation trigger. And then there's, of course, the peak of inflated expectation when everybody thinks, oh, this is the new hotness and everything's cool and everything, this is going to save us all from having to deal with the ops part. And then, of course, a lot of people fall flat on their face in the valley of disillusionment. And finally, people find out how this is actually useful and, well, have realistic expectations. There is a litany of Kubernetes failure stories already on the internet, for example, on the website k3s.af. And you can read about how big companies and small companies have failed with Kubernetes, and in a very spectacular way. And right now, as even banks are switching to Kubernetes because everybody's jumping on the bandwagon and everybody wants to be cloud native and agile and everything like that, Kubernetes is right up there on the peak of inflated expectations. So everybody's expecting Kubernetes to save them from having to do ops. Spoiler, it will not work this way. People will still have to do ops, and Kubernetes brings a lot of complexity that people will have to deal with. So how do you deploy Kubernetes? There is a bunch of deployment tools. Actually, this is just a very small segment of the whole ecosystem when it comes to deploying Kubernetes. You can, of course, go the classic way, the Kubeadmin way. Then there's kops, which is Kubernetes Ops. I believe it deploys on Amazon and some other cloud providers. Kubespray advertises itself as an enterprise-grade deployment tool. If you don't like any of those, you can do Kind, which is, funnily enough, in German means child, but it stands for Kubernetes in Docker. So basically deploys all the Kubernetes components in Docker. If you want a truly enterprise-grade solution, then you can go with Red Hat OpenShift or its open source alternative OKD. And you can also go with the low-priced open source tool Rancher. And all these deployments are, again, rather large in their size. So good luck finding the one that fits your organization. Now, the talk today is about something that the Rancher folks have developed, and this is called K3s. K3s it's a kind of funny way of saying we're going to cut K8s, which is the shorthand for Kubernetes, in half. So we're just going to split the 8 and make a 3 out of it. So this is a very simple way of deploying Kubernetes on a very small node. And the idea is that this should basically run on your average Raspberry Pi, or it should run on a small server or an embedded device or an edge system. Edge system meaning something that you can put on your shelf in your closet and just plug it in and it will work. So for example, your NAS or whatever. And the idea is great. So let's take a look what K3s does. There's, of course, competitors to K3s. A lot of companies have realized that there's no good Kubernetes deployment for small scale. So micro K8s is, for example, from Canonical, from the guys who make Ubuntu, and there's a bunch of other ones as well. So if you look at this piece of script, this is basically download this script and run this. Yes, if you're an experienced sysadmin, then this might freak you out, but this is unfortunately very often how we deploy things today. for whatever reason, and then wait about 30 seconds and then run k3s kubectl get node, and you will see that you have a Kubernetes cluster ready to go. So what does it do under the hood? If you look at the process list, the funny thing is you don't see any of the usual Kubernetes components. So you don't see any kube controller manager, you don't see kube scheduler, etc. You see a single binary. It's called k3s, and this k3s binary is running everything. You also don't see an etcd, and there is a reason for that. You, of course, see core DNS and metric server and things like that, but those are already running in containers. So we will talk about those in a minute. So resource consumption-wise, they're advertising it themselves as running in 512 megabytes of RAM. Well, almost. So 618 on an Ubuntu machine, as I measured yesterday. It's almost 512. You do need a gigabyte of RAM to run anything useful on k3s, which is still less than running 3 times 2 gigabytes of RAM just for etcd. So how is this done? Let's take a look at the architecture. You have one server, and this is the k3s binary, and that k3s binary, instead of talking to etcd, is talking to a SQLite database. You can, of course, plug in an external database, but the general idea is that this is a very lightweight SQLite database, local files only, and that's about it. If you want, you can, of course, cluster this. You can add additional nodes to your cluster, which simply contain a single k3s binary that will talk to the single k3s master. And this way you can build very small scale clusters and deploy applications in a resource constrained environment as well. So internally, the whole setup looks like this. You have, of course, your containers. They are connected using an overlay network. This is something that is usually called CNI, Container Network Interface. And K3s is using a variant called Flannel. And you can, of course, disable this, but K3s comes with defaults installed, which makes it very easy to deploy. It also comes with something called Clipper, which is a small load balancer that's running on every node. And that small load balancer is then connected to a reverse proxy called Traffic. If you haven't used Traffic before, it's a rather excellent little tool that takes care of, for example, getting Let's Encrypt certificates and things like that. When a connection comes in from on any node, it will end up on Clipper, the load balancer, and then Clipper will pass it on to Traffic. It does not matter which node the connection comes to, it will always end up in one of the Clipper instances and then be passed on to Traffic. Now, Traffic then will, of course, depending on the rule of the ingress rules, as you will see in the demo part, pass it on to the appropriate container or the appropriate pod. So that's their networking infrastructure. So adding nodes is also rather simple, because on the master node, you simply have to cat var libbrancher k3s server /token. That will give you a token. And then on the new node you want to add, you can run the same script with some environment variables, and that will connect, instead of installing a local k3s, it will connect to k3s master. Now, the funny thing is here, I complained about Docker Swarm not being, that I cannot deploy Docker Swarm in a stateless manner. And with K3s, this is no longer the case, because with K3s, you can actually tell the server what the token will be. So you can launch the master and tell it, hey, this is going to be my token. And then you can simultaneously also launch the worker nodes that will then connect, and you don't have to extract information from the Kubernetes master. You can just simply run everything asynchronously, which makes it very nice to deploy. As you might see, this is not solving all the problems, but it's solving some of the problems. So what does K3s include? First of all, it includes Flannel as an overlay network. This provides, basically, you can imagine this as a built-in mesh VPN. So it connects all the servers together, and to the containers, it looks like there's just one big internal network without having to interact with the cloud provider to do so. It also includes Traffic. As I mentioned, this is a rather excellent little reverse proxy that you can configure rather in a simple fashion. Core DNS is used for the internal DNS resolution and service discovery in many Kubernetes installations. So this is kind of standard. And it also includes Helm. Helm is a package manager, one of the many package managers for Kubernetes. I am not going to use Helm today in the demo. You could, of course, which makes it rather easy to deploy other components that you need in your Kubernetes installation. I'm going to use Kustomize. So, what are the problems that K3s is not solving? First of all, backup and restore. You only have a single master, so if you lose that master, then you're in big trouble, and because you have to reinstall everything. One of the open issues with K3s is that it is not documented what files you need to back up off your master and how to restore it properly such that it works after the restore. You could, of course, back up the whole varlib rancher directory, but that's kind of not the point. You want to have a documented backup and restore procedure to make this productive. And I'm really hoping that the rancher folks will address this. Second, it does not address the problem of storage. When you deploy a container on a K3s, then it by default uses the local storage. The same problem that Docker Swarm had. You can, of course, go in and use a different storage provider, but for that you will have to use some sort of a cloud controller or something like that. You have to provide it API keys, and that makes the whole process a little more complex. If you are not, if you don't have the luxury of running in a cloud, then you might have to have um, a local storage system such as a hardware storage, or you can run some sort of a vSAN if you're running, for example, in one of the enterprise environments, or if worst comes to worst, you will have to run your own Ceph, your own NFS server, or something like that. So that's definitely not going to make this a walk in the park if you want to have a highly available system where you can just simply replace nodes. But for a static workload, K3s should work rather nicely. The third, which I also mentioned, you don't have cloud integration, you don't have auto scaling. This is all not built in. You will need to configure this. You will need to launch additional components. So this is going to make your deployment a tad more difficult. I have done some initial implementations of K3s with cloud integration, but still I need to spend some more time in actually getting this productive. Talking about productive, you also don't have a monitoring built in. You do have a Prometheus exporter running, as far as I can tell, but you still need to have a monitoring system that will tell you if there's a problem with your Kubernetes setup. And K3s does not give you it doesn't give you any defaults in how to do monitoring for Kubernetes. So that's, again, something that you have to figure out yourself. And finally, it does not give you container registry. So if you're not just happy running publicly available containers, but you want to build your own, you will have to deploy your own container registry, such as Harbor, which of course you can do inside K3s, but you still need an object storage, you need authentication, and etc., etc. So that's still a lot of work to be done, but it is going in the right direction. And I think that K3s is something that might help us here. So with that in mind, it is time for the demo. What I have done here is I have installed a simple Ubuntu server. And I am going to just increase the font size a tiny bit so you can actually see what I'm doing here. 26, that should be fine. So I'm going to go to the K3s website. And I'm naively just going to copy this line here. So this is the installation as promised. So this is then downloading K3s from the K3s website. And now we are going to do kubectl get nodes, and we can see that the master node is already ready. If you want to take a look at how K3s is built internally, we can take a look. There is a couple of deployments. Oh, I see that I have actually, okay, so it looks like I have actually used an old server. So why don't I create a new server then? This will just take a minute. I will deploy a server with 1 gig of RAM. I was supposed to create a new server, but hey, such are the demo gods. So we will just create a new server right here. So we'll just take a minute to boot, and then we will stop the auto update procedure at the beginning so we can get this over with rather quickly. In the meantime, while this is booting, and it will of course not be available for a minute, please take some time if you have questions to join the Slido and ask some questions right there. We are in hall 3, of course, and you can post some questions there. I'm monitoring those questions. So here's our server. Let's take a look if the updates have already finished. I will just kill the updates because that would take unnecessary time right now. Oops. Okay. So back to the original setting, we are going to take this and install k3s on this server. So this is downloading k3s from the k3s website, and it's going to start our Kubernetes service. So I'll just take a moment. And that means that it's already running. So let's take a look. You can see that the k3s server is already running. Some containers also running. So let's take a look. K3s, Cubectl get nodes. So this is already up and running. All namespaces, you can see that there's still some deployments going on in the background. So when you are deploying this for production and automating the whole setup, you will still have to take a look at how to check if k3s is actually running. And this goes into the part that I told you about monitoring, that there is no guideline on how to monitor if k3s is up and all the components are running. So you will kind of have to figure that out for yourself. So you can see that the metrics server is already up, the local path provision is up, core DNS is up, traffic is still booting. And still booting. Takes a little while to get it done. And that should be it. And everything, and there should be still a Helm installer running at some point. Get pods. Let's take a look. There we go. So the Helm install is also completed, and this service LB is what I told you about, that little load balancer that's running on every node. So I did prepare a little bit of a script here that we can deploy. So we can do git clone. This is of course public. You can take this URL and run it publicly. So we're just going to clone this, and let's take a look at what I am doing here. So we have 3 files. We have customization.yaml, and customization.yaml is simply a link to the other 2 files, and it also creates a secret for the MySQL password. Since I'm not using this for production, I'm happy to show you this. So let's take a look at how I deployed MySQL. This is of course coming from one of the outdated official tutorials that I needed to update for this workshop. Unfortunately, this is quite a common occurrence, that since the whole Kubernetes world is moving so fast, this is a bit of a problem. So what's happening here? First of all, we are creating a service. A service is something that you can talk to. So this is for discovery. So the WordPress process will actually use this service to find the database. And then there's a persistent volume claim, which is a storage unit. It's allocated with 20 gigabytes of storage. And finally, we are creating a deployment. And this deployment includes the Percona database instead of MySQL. And it is going to create a WordPress user and a password for this from our secret that we created before, and is going to create a WordPress database. And of course, it's going to put varlib MySQL onto the MySQL persistent storage, persistent volume claim. Now, the other part of this is, of course, the WordPress deployment. And the WordPress deployment is consisting of an ingress, which tells, this ingress will tell traffic to send all data to any hosts, which, because we haven't specified anything, to this service, the WordPress service on port 80. The WordPress service is, of course, listening on port 80 for TCP and is with this selector creating an endpoint that is going to forward to this deployment down here. WordPress also needs a persistent volume claim, although in production you would probably use something like an S3 object storage instead of putting it on the local disk. And then we are deploying WordPress using the WordPress official image. This is what I said, that I'm just using official images here because K3s does not include a container registry. Now, the WordPress DB host, DB user, DB password, or environment variables are all set here. This one is coming from the secret. The other ones are hard-coded. Yes, I know it's not very elegant, but still working. We can, of course, output the container port 80, and we have a volume man for var www/html onto a storage. Now, to deploy this, we do Cubectl. Yes, you can use it without k3s. Apply -k for customization from this directory. And this will hopefully deploy everything. So let's take a look. Cubectl get pods. And this will only show the pods in the current namespace, which is just the default. And the containers are now creating. You can actually watch this. We will just wait a minute until the containers are created. Yes, there we go. It is already up and running. And if I am correct now, if everything is working, if I take a look at the public IP address of this server, then I will get a WordPress installation. Yes, I can go quickly through here. I will delete this anyway, so install WordPress, and this will initialize the database. And you will see that I do have a working WordPress installation here. That's how quickly it can go. Now, as I said, I will destroy this, but before we do that, let's dig into its soul a little more. So we have a couple of minutes left. So you can see that the endpoints have properly been created. These are internal endpoints. And we can also take a look at the services. They are also created. And the ingress as well. Again, the source code for this is up on GitHub. And with that, we switch a little bit to the questions. So we have one question on Slido. You still have about 3 minutes to post them. Does any cloud provider already use K3s? As far as I know, the answer is no. The reason for this is that if you are a cloud provider, then K3s is not really an option for you because you have to deal with a lot of things. It's very young, so it just came out, I believe, a couple of months ago. And every cloud provider that builds Kubernetes usually wants to provide additional services, and they want to integrate, for example, the Kubernetes authentication with their own internal permission management. K3s is a standalone product, and its main purpose is to deploy on a small scale environment, which makes it very unattractive to cloud providers. So I don't think K3s is going to be something that's deployed by cloud providers, but it is CNCF certified, I believe. Yes, it's certified. So it works exactly the same as any other Kubernetes distribution. So the same script that I used for K3s to deploy WordPress here, you could now use for deploying it on another Kubernetes, which is not K3s. And that's the point of having a certified Kubernetes distribution. So to a cloud provider, it doesn't really matter. And to you as a customer, it should also not matter what the cloud provider is using, as long as they're providing a good service. K3s is interesting for you if you want to install something on your laptop, if you want to install something on your Raspberry Pi, or if you're working with a cloud provider where the Kubernetes offering is too expensive or doesn't exist, then you can use K3s to deploy it in a rather simple manner. In my day job, I work for this cloud provider that I showed here, Exascale, and in my GitHub repository, you can also find a Terraform script to deploy K3s on Exascale. If you want, you can just as easily adapt it to AWS or any other cloud provider if you wish. Again, feel free to follow me in that respect. So with that in mind, conclusion. I think K3s is a great tool. There are some doubts if Rancher will continue updating them, because they have apparently killed products before. I don't know about that, unfortunately, but it is a very new product. It is a very lightweight product. It can be very useful, but I'm very happy that finally the Kubernetes world is waking up and is going into the direction of Kubernetes being available to smaller companies, to smaller deployments, and things like that. And with that in mind, if you still have questions, you can still post them on Slido, or you can, of course, join my Discord channel at pasztor.at/discord. And all my content that I write, that I create, is available on my website. This slide deck and many other slide decks will go online in about 2 to 3 weeks once I have finished the overhaul of my website. And feel free to follow me on Twitter, Facebook, and wherever else. Thank you very much for your attention. If there are no more questions in Slido, then I wish you a bon appetit. I don't know how you even say this in English. Have a very good lunch and enjoy the rest of your conference. If you're interested, I will be holding a talk on testing containers before they go into production tomorrow, I believe. So I would be very happy if you could join that talk as well. Let me just check. Yes, so tomorrow morning at 10:10 in Hall 3, I will be talking about behavior testing your containers, which is also a rather interesting QA topic if you're building any containers yourself. Thank you very much for listening and have a good one. Goodbye.